Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology turned podcast. Everyone, welcome into the program. Today on the show, it's Friday, so you know what that means. That means it's the one, the only Mr. Ralph Bond. We'll be talking all about a bunch of different stories, 4 different stories to be exact. And everyone, you're definitely going to want to hear about these. They are stories that you might not have heard of, and if you haven't, then you definitely want to. These are all very, very cool. And yeah, everyone, I'm looking forward to this. So before we get started, computeramerica.com. That's where you'll find everything, including past shows, future shows, show notes, podcasts, archives, video archives as well, social media links, contests, giveaways, news, and more. So while you're there, be sure to check that out. And of course, go out to social media and give us a like, give us a follow. That definitely helps us out as well. Now, with that being said, why don't we go ahead and jump right in? If you can't tell, I've had my coffee and it's very, very tasty. So everyone, let's go ahead and just jump right into this. And he is our science and tech trends correspondent here on Computer America. This is Ralph Bond, and of course, longtime contributor to the show and all-around nice guy. Ralph, how you doing?
I'm doing great. I'm also highly caffeinated as well.
You know, this, and honestly, no other way I'd rather be. But I hope that you're doing well, and it's, and I hope that it's been a good week for you. And although, let's face it, let's just talk about the weather. It's still really dry up there because I've been hearing like the droughts up there are pretty bad.
Yeah, it's been a while since we've had any measurable rain at all. So yeah, it would be nice to get some. And we're having these more days pushing 100 degrees than I can ever remember in nearly 30 years living here in the Portland, Oregon area. So if you don't believe in climate change, people, we could show you some changes up here. And of course, the rest of the country is going through a lot of crazy stuff. Terrible rain. What was it in Kentucky? Those horrible floods and all that stuff. Oh my goodness. God bless those people. Wow.
Definitely wild. But okay, so the weather could be better, but I think the stories can't be much better because they're awesome this week. And that's my best way to segue into this. Ralph, let's go ahead and tell the nice folks what your mission is here, doing this segment with us.
Sure. If you're a first-time person listening to Ben and I go together on these stories, I'll tell you what I do. I'm an aggregator of science and tech news features I find by monitoring a host of online news outlets all day. I love it. I look for important and sometimes the stuff I look for is kind of wild and out there stories that usually don't capture mainstream press attention, or they're very significant scientific or technology advancement stories that for a host of reasons just don't bubble up to the nightly news on your TV. I'm always on the lookout for news that gives a glimpse into where we're headed in robotics, medical technology, sustainable energy technology, transportation advances, space research, physics, you name it. It's all across the board. And what I do with each news item is present the essential points and in a digestible form. And I stress to our audience, as you have too, Ben, go and get the show notes for today's show because it'll give you the links to the articles so you can dive deeper if you want to. Because again, we're just going to, like a stone skipping across the surface of the water, just giving you the high points of what we're doing.
Definitely. And of course, we're going to have all this up there right after this. And of course, by the time you're hearing this, definitely be able to go and check that out. But I think, Ralph, with that being said, let's go ahead and jump right into story number 1, which if you're, watching the video portion, you can see it right there. And, we did talk about this with a different airline company, and I think it was Ammonia as well, where it was planes. But this time it's NASA, and at least they're back in the research to this, so it's getting more real.
Yeah, and boy, 2022, Ben, I think you'll agree with me, at least in the stories that you and I've been doing together. NASA. Of course, MIT is always there, Northwestern University, many other institutions in the United States, but NASA has been so active, everything from the James Webb telescope to all kinds of things. And we all need to remember that NASA is not just outer space, okay? It's aeronautics, right? And space administration. So this is a story that fits nicely into that bucket, and that's why I liked it so much. So the headline here is new NASA-backed study will test ammonia as a carbon-free jet fuel. And I got this from the Robb Report article, and then that led me to the University of Central Florida, and you'll see how that applies to their newsroom as well. So let's set the stage here. Just this year alone, it's estimated that commercial jets will dump 671 metric tons of carbon dioxide into the atmosphere just this year. And one thing to point out here is a metric ton is also equivalent to 2,204.6 pounds.
Wow.
Okay. So we're talking about a total in just this year of 478,000 tons of or pounds rather of this material going into the atmosphere. Just awful, just terrible. So that sets the stage. We all know it's bad, and here we go. But 2 weeks ago, also a little reminder, 2 weeks ago, we talked about an experimental solar tower that can make green jet fuel from sunbeams, water, and carbon dioxide. And a few weeks before that, we talked about a farm tractor retrofitted to use ammonia as a fuel. So that's kind of a fun thing. We're seeing a little bit of this traction on ammonia. And the good news is now is the search for climate-friendly alternatives to traditional jet fuels continues to expand thanks to a new NASA $10 million grant to the University of Central Florida. So that's where Central Florida comes in. And the grant will fund a collaborative academic and private industry research effort to see if liquid ammonia could be a carbon-free emissions alternative to today's kerosene-based, petroleum-derived jet fuel. And wow, what a great team they've got here. It's the University of Central Florida here, but also Georgia Tech, Purdue, Boeing, General Electric, ANSYS, Southwest Research Institute, and the Greater Orlando Aviation Authority. All of these folks together with the university here in the Central, University of Central Florida, I'm trying to say. All of these folks coming together. I love it. I mean, that's the kind of collaboration you need to make something really happen. So, but I also want to do a quick history aside about ammonia. I started thinking to myself, when did this all start? The idea of maybe ammonia could be a source potentially for a combustible fuel for internal combustion engines. So I did a little dive into the Google, and using ammonia as a fuel for internal combustion engines, dates back to the early 1800s. And that conflicts with something I found I'll mention in a moment here, but I'll go on to say, and saw a surge. So they say in the early 1800s and saw a surge in use as an alternative fuel during World War II. And I went, what? That's interesting. When oil stockpiles became low. So the use of ammonia for a fuel for internal combustion engines was going on in World War II when we couldn't get enough oil, right?
Yeah.
Isn't that interesting?
And a lot of what we're hearing now, I was also thinking in the back of my mind, I'm wondering if all this research is especially making headlines because oil prices are so high right now. Maybe we need some other alternative fuel to, kind of maybe fill in the hole. So happened in World War II, happened before. Yeah. Makes sense. Yeah.
And so it goes on to say, despite this early start, limited research on internal combustion and spark ignition engines using ammonia as a fuel had been conducted until the 2010s. So it's around the 2010s that the interest starts kicking in again. And there's a source here in the show notes for you as to where this article came from. But you raise a really interesting point. As terrible as gas prices being so high are, it's bad. It hurts everybody's wallet. I get it. But it also, though, is a forcing function, to your point, when you add climate change as a forcing function and oil and gas becoming so expensive, it will force us to look for alternatives that are hopefully green and possibly less expensive. So that's an interesting side note. And then another little tidbit of history. The first internal combustion engine was invented by a French engineer, J.J. Etienne Lenard, in 1859. Ding! It was a gasoline. Isn't that something? It was a gasoline engine with an ignition system. The engine was able to run continuously. There were earlier attempts to build an internal combustion engine, such as the engine built by Dutch physicist Christian Huygens in 1680. What? I mean, even 1859 just blew what's left of my hair off. But I think it goes back to 1680. Wow. Okay.
Well, yeah,
well, that was
they tried the external combustion engine, but that just kept blowing people's fingers off. So they said, we have to make this internal. So it makes sense. Took them a while.
Yeah. So now back to our story, back to our NASA $10 million grant for this research effort. So the goal of the 5-year effort is to prove that liquid ammonia can provide enough power to fly a large commercial passenger jet. And the plan is to use ammonia. Now, here's where it gets interesting. And you remember this from the tractor story we did before. When you say ammonia as the fuel, it's ammonia as a source for a process that leads to something you can burn in the engine. So with that said, here's the deal. The plan is to use ammonia as the hydrogen carrier, which will then be catalytically cracked. Remember that discussion of cracking? To release nitrogen and hydrogen. And the hydrogen will be burned in the onboard combustors inside the engine to provide the power. And this is the same concept we talked about with the ammonia-powered tractor a few weeks ago. Right. So it's not literally ammonia, it's ammonia being catalytically cracked to create nitrogen and hydrogen, and then resulting hydrogen is then the real combustible element of the whole fuel equation.
Yeah, so it's not just a one-to-one pouring ammonia instead of kerosene. It's, it can be retrofitted to work.
Yeah. And so my friend Mark Mason, the host of the KEX show that I also do, yesterday he was joking. He said, so I can't just kind of pour my Windex into my gas tank and start driving? No.
If only.
So to achieve this goal, the team will develop new jet engine adapter components needed for the Boeing 737 test aircraft. That's what's shown in the show notes picture, to convert to using the liquid ammonia fuel the team plans to create. And again, remember what this means about liquid ammonia, okay? Overall, the research aim is to not only make aviation fuel green, but also to create engines and fueling systems that easily integrate into a current airport infrastructure. That's a key point, thus saving airports and aircraft manufacturers millions of dollars as they look to retrofit. So if you can't retrofit fairly seamlessly, it's going to be a dead idea. But if you can figure out a way to not only make this fuel, but also make it easy to implement in existing infrastructures, then you've got a winning combination. And the University of however, there's a little interesting nugget here. The University of Central Florida led study is not the world's only effort to explore the use of ammonia as a jet fuel. For example, there's an Australian company called Aviation H2 that's announced plans to operate a smaller business jet using ammonia fuel by mid next year. And in fairness, actually, if you dig down deep, what that company is saying is we're going to kind of do a hybrid where part of the fuel solution is ammonia based, and with other things like electric and so on and so forth. So it's a hybrid scheme. But it is so interesting to see the world now coming back and looking at this. And again, I was so blown away to think that during World War II, we were using ammonia-based fuels way back then. Go figure.
Yeah. Much like I'm sure some people do not recall because they weren't around, but the first cars were, electric cars. They were steam powered and we had to crank them up and they had to do that whole thing. The first cars were electric. We found out that, hey, burning liquid dinosaur is just so much easier, faster, and, has so much energy. But now, Ralph, that we need more than just, it's easy and cheap. We need to make sure it's sustainable. Now we come back to the ideas that were, we were batting around before. So I'm hoping to see it, tractors and now airplanes, and really, and I'm trying to think other than like maybe the other things that NASA flies, the space shuttles and rockets and stuff like that. Those are like two of the biggest things I can think of that you need fuel for, because kind of everyday commercial cars, they're pretty small. Big old semis, hauling freight and stuff like that are pretty big. Like maybe cargo ships, like if they can nail passenger, what I'm trying to say is if they can nail passenger jets, that's a huge engine and a great use of sustainable energy. And then you could, of course, shrink it down and hopefully turn everything else below it into ammonia.
Yeah,
that'd be great.
Exactly.
It's certainly something different. And again, just any way to kind of clean things up without having to do extra work. That's my goal is, just let's fix it at the source, instead of making every single person, kind of do their part, which they should, but this is much more efficient. So story number one. Story number two, don't think it runs on ammonia, but hey, I think I remember seeing these. I'll have to look at my phone while you do the story. I think these nice folks were out there at CES 2020 just for the pandemic hit, but they were actually showing this off on the show floor, and I think I have a picture of it. So let's talk about story number two while I look for that.
Yeah, story number two. Headline: New one-passenger flying car does not require a license to operate. And I got this from planeandpilotmagazine.com and from the companies in question, their website, JetsonAero.com. And I just love it. Maybe what you saw at the show you're referencing maybe was a prototype. I don't know.
Yeah. Oh, yeah.
But a little setup here. When I was a kid, because I'm an old guy, I loved the Jetsons, a cartoon show from the 60s about a family in the future that featured a single passenger flying jet that folded up into George Jetson's briefcase when he arrived at work. So that was actually the opening to the little cartoon series. Yeah.
Did you see the little fun fact that I think it was like July 22nd was the fictional birthday of George Jetson of July 22nd, 2022 or something like that was the fictional birthday. So everyone's like, hey, somewhere out there, George Jetson was just born. So
yes. Yeah. And I think the story, the show was supposed to be in 2045. I think that's what it was. Something along those lines. So there was some anniversaries of the cartoon show just coincidentally lined up with this story, but I thought this is really cool. So the fantasy in a way has partly come true in the form of a new single passenger flying craft that to me kind of looks like a sleek open bar toboggan-like shaped thing with 4 big drone propellers. Mm-hmm. Now it's called the Jetson 1. Gee, no surprise, in honor of the cartoon series. And it's an 8-foot-long recreational, all-electric, vertical takeoff and landing vehicle developed by a Swedish company called Jetson Aero. I think it's so interesting that a Swedish company is so on to an American cartoon show. Maybe it was popular worldwide for that matter, for all I know. Mm-hmm. And here's really cool thing here. And because it's classified as an ultralight weighing only 190 pounds with a top speed of 63 miles per hour, it does not require an FAA certificate to legally fly it, which is good and bad at the same time if you stop and think about it.
It means that anyone could be flying one of these, almost like the size of like a motorcycle, but of course it's flying over your head.
Yes. So the Jetson 1 can support a passenger weighing up to 210 pounds and offers a surface ceiling of over 1,500 feet. That means the maximum height at which the aircraft can sustain a specified rate of climb dependent on engine type. That's aeronautics geekdom for you there for a second. And the craft, but the part that I really like a lot, which makes me feel a little bit better about anybody can jump in this thing and start going, the craft features a triple redundant software-driven control system, which allows virtually anyone, even those people with no flying experience, to safely fly the aircraft with very little instruction. So you do have a little bit of training. You can't just walk up to it cold. Right. The design includes multiple automatic safety systems, including the aircraft's ability to hover hands-free simply by taking your hands off the 2 joystick controls. It will automatically go into a stabilization mode. I think that's the programming behind that is pretty impressive. Other safety features include LiDAR sensors for terrain tracking and obstacle avoidance, as well as a rapid deployment emergency ballistic parachute big enough to safely land the craft and the passenger. And that whole thing about ballistic parachutes, I did some research on that. They're fascinating. And ballistic means this thing deploys really fast.
Right.
And the idea is it's going to protect the craft and the passenger. So remember, A quick reminder, if you're not familiar with this, LiDAR, which stands for Light Detection and Ranging, is a detection system which works on the principle of radar. So it's similar to radar, where you send a sound out and you wait for it to come back, bounce back, but it uses bounce back light from a laser to measure distances. So again, this craft uses LiDAR sensors for terrain tracking and obstacle avoidance. That's also a very interesting technology. And then for battery, it uses a Tesla high discharge lithium ion batteries. And as a result, the Jetson 1 can keep you airborne for about 20 minutes. Well, fun, interesting, wild, and crazy. Let's have a little reality check when it comes to your pocketbook, your wallet. Purchasing one of these Jetson ones will set you back $92,000. So I think you're not going to see this in every neighborhood.
Well, no, and I'm sure that the FAA, and I think recently the FAA, and by recently I mean like in the last year, made it so that you had to any drone over, I think it was like 5 pounds, you had to register with the FAA, and you can only fly it in certain places. So you would have to, even though you don't need any kind of license and just a little bit of training, you could not fly this, from work to home, even if you were within 20 minutes of your work. But it's still very, very cool. And Ralph, I will say this, $92,000, very expensive toy, but at least you can buy one. And that, I guess, is kind of the start of the future. Yeah. It's like, before they're 10 years ago, couldn't even get one. Now you can get one, but they were super pricey. Maybe in the future, it's like, hey, would you like a jet ski or would you like a Jetson 1, and it's, it's an oversized drone that you can sit in, you can pilot in, and I'm actually curious, what the weight limit is. 210 pounds. For the passenger, yeah. My diet has to kick in real soon if I'm going to get one of these. This is man.
So here's Ben. Here's some other things to think about this. You and I've talked so many times about drones and their potential use for police, fire, military. This on the surface was presented as kind of a wealthy person's toy, but wow, wait a minute. What if you're in drones are great. They've been a huge help for a fire department that gets on site. They can send a drone up and look and see, the fire's in this part of the building and get visuals they couldn't do. The same for the police, certainly for the military. Now, 20-minute flying time is a bit of a limiter, but think about this. If you could deploy a human in a big drone, you get the added value of the human's ability to communicate and do things that just a drone with a camera couldn't do in terms of value add from the old brain here. So I think that's, to me, in the end of the day, the really exciting thing about this recreation fun. You could see people, companies buying several of these things and setting up fun things at county fairs for people to try out, all that kind of stuff. You can see that. But I think the serious purpose could be police, military, fire, and that sort of thing. Rescue, search and rescue.
Search and rescue. For that kind of thing. And I will say the only other one that I really liked that we did a couple of years ago was they were using a drone in places in Africa and very remote places to kind of ship, to quickly deliver organs, for organ transplants because they had to go so quickly. Being able to get, medical care, first aid, things like that. Let's say places out in the desert or in the forest, hikers and things like that. Medical aid, this would be great because you could take a paramedic and probably, a bag and get to someone very, very quickly. So lots of use cases.
And in this case, in this case, you could transport the paramedic and the materials needed right to a difficult to access site with one of these, like you say, passenger drones. There's a lot of possibilities. It's kind of fun.
And a defibrillator hooked up to a Tesla high discharge lithium ion battery. So you're really going to, shock Frankenstein back to life with that one. That one's going to be something else, but still, that's certainly great. Looking forward to it. And I always love these. They're essentially oversized drones that you can sit on. And, that is going to be a trend we're going to see more and more of. So looking forward to that. Story number 2. Story number 3, though, and this is something that, we either covered something like this or it was an earlier prototype of this.
No, you're right.
Ladies and gentlemen, if you enjoy Legos, this is your chance to kind of relive that. And hey, maybe even not just relive, but live in that. So story number 3.
Yeah. So story number 3, and you're right. This relates to a worldwide effort to look at how could we possibly use plastic waste repurpose it for construction purposes. So the story we're about to do is certainly not the first effort to do this. And by the way, your aside about Legos and snapping together and so forth, actually, gosh, a year or more ago, we did a story about in Holland, where they're working with taking plastic waste, compressing it and forming it into building blocks that do interconnect, do so-called snap together for roads, making roads, retrofitting roadways with this. And there were multiple levels of benefit. But let's get into this story. This is just kind of a good example of the continued research worldwide, not unique, not the only effort, but a new one, a recent one. So a new system transforms non-recyclable plastic, that's the key, into construction building blocks. Got this from a website called interestingengineering.com. Fun website. Check it out, folks. And here's the story. So let's set the stage. Every year, nearly 27 million tons of plastic waste winds up in American landfills. Get out your calculator and think, what does that mean over 20, 30, 40, 50 years? And it's probably increasing every year. Horrible, right? Just terrible. So a Los Angeles-based startup called ByFusion, BY Fusion, run together, has come up with an innovative way of dealing with plastic waste that can't cost effectively be recycled. I did a little research, and technically speaking, all plastics could be literally recycled, but the cost to do certain kinds of plastic recycling is so prohibitive that in effect, it's non-recyclable, if you get my point.
Yeah, and I think during the pandemic that really was highlighted by the fact that our masks are are made out of plastic, and of course the single-use nitride gloves and stuff like that are made out of plastic.
Yes,
those get thrown away all the time, and we certainly use a lot of them, but they certainly are not recycled, or at least they're not recycled, as easily.
Cost effectively. Yeah, exactly right. So what this bunch ByFusion has come up, they've developed a way to turn plastic trash into useful construction blocks. So they call them By blocks, by using a machine they developed that transforms the plastic waste into building blocks in minutes. And this is what I think is so kind of cool and funny at the same time, using steam and high compression. So it's not some exotic technology in a way. The machine might be very advanced, but steam and high compression. Well, that's not from outer space. That's pretty down to earth. One of the key advantages of the ByFusion solution, one that's financially and process time attractive, is that the plastic trash does not have to be washed before feeding it into their block making system. Now, I immediately thought about my wife and I love this one Japanese takeout food place. We almost hit it every week. And it loved the food, but unfortunately, they put it in these black plastic, dish-like things with a plastic top that are technically non-recyclable. And every time I have to throw those in the trash, I just, but they have food. They have food matter on it.
Yeah, they're food safe. I will say that those they are okay. So they're not recyclable, but I believe those are reusable. So something to think about. So you can maybe wash them and use them, because I use the same thing for like my meal prepping and stuff like that. But for every person that reuses those kinds of things, Ralph, there's 100 others that just throw it in the trash. You're right.
Well, yeah, and that's it. And we've saved up some and used them for different purposes, but after a certain point, anyway. Yes. So, but the point is that a lot of that kind of waste, we rinse our stuff out pretty good before we toss it in the trash. At least we do that. But a lot of people, of course, are not. And fast food situations, McDonald's, whatever, a lot of stuff, plastic stuff's going to go into that bin with residual food material. And if you had to clean that plastic in order to do this process these ByFusion guys in Los Angeles have come up with, it would be prohibitive. It would add a layer of cost and time and process that would just make it not a practical idea. So they have come up with this steam, and I bet the steam might be part of the equation to eliminate the need to wash the plastic first. That's very cool. I think it's a cool thing. So the ByFusion system takes the plastic trash, as we've been saying, as is, and shreds it into tiny pieces that can easily be fused together to make ready-to-use construction blocks measuring 16 inches by 8 inches by 8 inches that can serve as substitutes for, and here's the ding, 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 their form factor makes them substitutes for standard hollow cement building blocks we all know and love and seen everywhere. So, but reality check. The By blocks work just as well as cement blocks. But they have one catch. They're susceptible to sunlight. So that that part of it. You can't just have what you see in the picture in the show notes, the blocks just sort of sitting by themselves. You have to coat them with a clear paint or pairing them with a durable weather-resistant material in order for this to be successful, because apparently when they're exposed to sunlight over a long period of time, they deteriorate. But if you encase them, as shown in the show notes, I think there's a picture showing how they're encased, then they can become practical. So the question is, how much of a financial deterrent is having to encase or coat them in terms of being used for construction? Hopefully not too bad, because I think the idea could be just profound. But the other thing, Ben, I thought about too in this story. So say you start going to the landfill and you say, we're going to gather up all this stuff. How do you quickly and economically sort out the plastic from the regular garbage? Or would this mean, if this got enough volume and enough worldwide distribution, or at least in the United States, if you had enough of these bifusion kind of systems or systems similar to them in all over the United States, you could tell consumers, hey, you can put any kind of plastic, any plastic you want into your recycle bin. Here where we live in outside of Portland, Oregon, every 2 weeks they come and we have a recycling bin, but it's very restrictive as to what I can put into it. What if they said, hey, Ralph, guess what? Starting on this date, any plastic, don't care what it is, you just toss it in there, because we've got a way to deal with it. So those are the reality checks but otherwise I think is a great idea. And let's keep going and trying to find ways to solve this problem.
For sure. And coding it seems like the smallest problem, because even like new construction that we do nowadays, if you've ever seen a house go up, and I've seen a lot of houses go up around here lately, I mean, all of them are wrapped in Tyvek, before they put on the siding. So
that's true.
Any kind of building that is currently going on, I'm sure that if you use these instead, you would also, and they even had like a little video on their website, kind of show, well, actually it was this video that's included in that article.
Yeah, there you go.
And, when they're building this kind of shed here, and they kind of show how they kind of stack it up, and then eventually they wrap it in Tyvek, and then it's good to go.
Yeah.
So, not the biggest deterrent, but I am also kind of curious because, you see, Ralph, what they've built and kind of the examples that they have. My only question is, what happens to, I guess, kind of like the durability of these things when you cut them in half or shape them, a little bit different for different kinds of applications? Because so far, everything that they've shown is block or square shaped, which, if that's the only use case, it's good. That's good. But like, Ralph, if you cut it in half, does it lose its structural integrity because the form isn't, what it was? I don't know. But still, it's a really, really good idea.
Yeah, my guess, Ben, is they're just assuming you're going to use these things as concrete blocks are used. You're not going to be cutting them up or modifying them. You're just going to use them as is. But that's my guess. But you raise a really good point.
But there's still plenty of uses for the humble concrete block, and of course, maybe in the future, the plastic block. So, perfect. Love to see that one. And they. I think in the article there at the end, they have a lofty goal to recycle 100 million tons of plastic by 2030. So
let's hope so.
That's a better goal than I had to recycle. That's definitely very good. So our last story, and then we're going to cap this one off here, is with story number 4. And we were just talking about organs. Ladies and gentlemen, if you have a pig on death's door, this is a story for you. This is going to be really good. So, story number 4. And no, there's a lot more implication, but yeah.
And you made a passing reference to Frankenstein earlier today, so you'll see how this ties in a little bit. So the headline here, a simplified headline, and that's one thing I do, folks. Sometimes the headlines I create are simplified. They're not the literal headlines from the source, but go to the source if you're interested to see that. But researchers revive organs in dead pigs. And first I got this on the National Post, and then I went over to CNN and saw their research too, and other sources too. But here we go. Cutting edge medical research on pigs, or using pigs, is showing that death in cells is not instantaneous. In fact, it's a complex biological process that can potentially be halted. Scientists from Yale University recently reported that they reanimated the cells and organs of pigs that had been dead for an hour using a treatment involving synthetic blood and using a system they call OrganX, ORGANEX, that involves special pumps and a cocktail of chemicals to restore oxygen and prevent cell death throughout the body. The Yale University team restored blood circulation and other cellular functions in multiple pig organs an hour after the pigs died from cardiac arrest. Wow. Okay, according to the research team, the study reveals the underappreciated capacity for cellular recovery after prolonged whole body loss of blood circulation and resulting loss of oxygen in a large mammal. Well, time out. Okay, here's where the Frankenstein part comes in. If you're thinking that this is just some kind of morbid, weird science thing to create Frankenstein pigs, no. Think again, of course not. Instead, and this is why I think this story, Ben, is one of the most profound medical technology stories you and I have ever done. Instead, the exciting and wonderful goal of this research is to expand the window of time that much needed human organs for transplants can remain viable. Wow. A triple plus on this. Wow.
Yeah. It's, and you know, and the article also gets into this a little bit more as well. But then the question of, well, you know, if you can revive organs, Ralph, you know, after declaring time of death, and they usually wait about 5 minutes, you know, and that's according to the article. What is time of death if we can start reviving parts of the organ? And obviously, you know, reviving an organ here and there isn't so much as like, oh, I'm dead. And then an hour later, oh yeah, we gave you a treatment and you're back up. You know, you can go ahead and go back to work the next day. Probably nowhere near that, but it does kind of question, you know, what is dead and if there's maybe something else they can try after you're dead. So very strange. It
is. And you raise a good point because some of the articles related to this or about this same topic raise the issue of kind of redefining what is death. Yeah. Right.
It's certainly strange, but you know, and honestly, I think one of the biggest things that we can accomplish here in the next couple of years, between all the stories, Ralph, that you've given me hope by, you know, kind of coming on the show with, are either creating new organs or finding a way to modify existing organs and really help people who, you know, maybe they have a bad heart, they have bad lungs, they have bad kidneys, they have, you know, just something wrong that would normally be a death sentence. Maybe we can get them the help that they need in an organ that would just save their lives. And that, Ralph, feels like a solvable problem thanks to you. So
yeah. Well, you know what, and you remind me that there's been a lot of research in the last year or so on transplanting pig hearts into humans instead of having to wait for a transplant for a human heart. That they're getting really good at figuring out how to pull this off. So not great for the pigs. You know, it's a bad deal for the pigs because these poor pigs in this case were induced cardiac arrest.
I'm sure that there's a human, or I should say, an animal rights group out there that is working on the opposite, to put a human heart into a pig and save the pig's life. I'm sure that is maybe complete joke. But everyone, I will say that with that, we are probably out of time. Everyone, thank you so much for tuning into the program. Thank you, Ralph, for coming back on every Friday. You can check him out here. And actually, Ralph, I have something to talk to you about next Friday, and I'm actually heading out of town, so probably have to either do that Thursday if you're available, or we'll figure out when to do that. But everyone, thank you so much for joining us on the program. We'll catch you next time. ComputerAmerica.com, and of course Ralph Bond-Wicks. If you want to search that in Google, it'll come right up. Or check out the show notes. We'll have it there as well. Until next time, have a good one. Bye, everyone.